Welcome back, everyone. Today we're diving deep into our own backyard, cosmically speaking. We've got some amazing material here covering our solar system.
That's right. Everything from, the planets and moons to asteroids, comets, the whole neighborhood.
And our mission really is to uncover some of the secrets, the genuinely surprising things about this place we call home in the universe. And you really have to start with the sun, don't you? It's the anchor for everything.
Absolutely. I mean, it's almost all there is mass-wise. The sun contains, 99.8% of all the mass in the entire solar system.
Wow, 99.8%. So all the planets, moons, everything else. Okay. Just crumbs, really.
Exactly. Just a tiny fraction. And its gravity, that immense pull, is what holds everything together. It orchestrates the whole dance,
That scale is just hard to grasp. And inside, it's this nuclear furnace fusion happening.
Precisely. Down in the core, you're talking temperatures over 15 million degrees Celsius. Insane pressure. Yeah. And under those conditions, hydrogen atoms fuse together, creating helium. And that process releases just, colossal amounts of energy. That's what makes it shine.
And the energy output is astronomical, right? I read that the tiny bit hitting Earth powers, everything here.
It really does. Every second, the sun pumps out more energy than humanity's ever used in its entire history.
That's unbelievable.
It is. And Earth intercepts only this minuscule fraction, like feeling a tiny bit of warmth from a gigantic bonfire miles away.
Okay, so that tiny fraction is the reason we're here, essentially. Life, weather, seasons.
Couldn't happen without it. No sun, no warmth, just a frozen rock. It drives our weather, gives us seasons, provides the light and energy for life itself. It's the engine.
Right. So starting from that engine, let's head out to the inner planets, the rocky ones.
Yeah.
First up, Mercury.
Okay, Mercury. Closest to the sun and also the smallest planet. It's a world of, let's say, extremes.
Because it has no real atmosphere. Right?
Yeah. Pretty much, yeah. No blanket to hold the heat. So the temperature swings are just dramatic. Daytime, you can hit 430 degrees Celsius. Hot enough to melt lead.
Ouch.
But then turn away from the sun, night side, and it plunges down to minus 180 Celsius, freezing cold.
That difference is just wild. And visually, it looks a lot like our moon, doesn't it? All those craters.
It really does. Very similar surface. Like the moon, no real atmosphere means no protection from impacts over billions of years. So yeah, heavily cratered, pockmarked.
Okay. Next up, Venus. Often called Earth's twin. But maybe evil twin.
Huh. Well, similar in size, yes. But that's kind of where the comparison stops. Venus went down a very, very different path.
Its atmosphere is the killer, isn't it? Super thick.
Incredibly thick, mostly carbon dioxide. And that CO2 traps heat like crazy. It's the ultimate greenhouse effect, a runaway version.
So it ends up being the hottest planet. Even hotter than Mercury.
Yep, hotter than Mercury. Surface temperatures over 460 degrees Celsius. It's roasting.
And the clouds aren't water vapor, are they? I remember reading sulfuric acid.
That's the one. Clouds of sulfuric acid droplets. Highly corrosive. Add to that the atmospheric pressure, which is about 90 times Earth's.
90 times.
Wow. So thick, hot, acidic, high pressure. It really is like a giant pressure cooker. Not exactly vacation friendly.
Definitely scratching Venus off the travel list, which I guess makes our own planet, Earth, seem even more special. The only place we know has life.
Absolutely. Earth hit the jackpot, really. We're in the habitable zone, the Goldilocks zone. Just the right distance from the sun for liquid water to exist on the surface.
Which seems key.
It's crucial for life as we know it. Combine that water with our protective atmosphere, moderate temperatures. It's a unique blend.
And it's humbling, isn't it? We live here, but we're still figuring so much out about our own planet.
That's a really important point. We're constantly learning more. The deep oceans, the core, the complex climate interactions, the biosphere, still so many mysteries right here at home.
Okay, moving on again. Past Earth, we get to Mars, the red planet. Always captures the imagination.
It really does. Mars is, it's cold, it's dusty, thin atmosphere compared to Earth, but it does have some familiar features.
Like seasons. And ice caps.
Exactly. It has seasons because it's tilted on its axis, much like Earth. And it has polar ice caps, mostly water ice and frozen CO2. Plus, lots of evidence points to liquid water flowing on its surface long ago.
And those massive dust storms, they can cover the whole planet.
They can, yeah. Pretty dramatic events. Solar heating drives them, and they can grow huge, obscuring the entire surface for weeks sometimes. You can see them from Earth with a good telescope.
Wild. And of course, there's the ongoing search for signs of past life, maybe even present life, under the surface.
That's the big driver for a lot of Mars exploration, looking for evidence of ancient microbes, potentially hidden away underground where conditions might be more stable. Still searching.
Fascinating. Okay, big jump now. Across the asteroid belt, out to the gas giants. Starting with the king, Jupiter.
Jupiter is just immense. It really is the king. So massive, you could fit all the other planets inside it easily.
All of them. Wow.
Yep. And about 1,300 Earths could fit inside its volume. It's mostly hydrogen and helium, like the sun, but just didn't get quite big enough to ignite fusion.
And it has that famous great red spot, that massive storm.
That's right, a gigantic anticyclonic storm, bigger than Earth itself, that's been churning away for centuries. We've observed it for at least 300, maybe 400 years.
Centuries. That's incredible persistence for a storm.
It shows you the kind of powerful dynamics happening in Jupiter's atmosphere. Winds there are incredibly fast.
And Jupiter's not alone out there. It's got a huge family of moons, right? Like its own little solar system.
It really is like that. Over 90 known moons now, and we keep finding more. They range from tiny captured asteroids to huge geologically active worlds like the Galilean moons. It's incredibly diverse.
Yeah, next giant. Saturn. Famous for the rings, obviously. They're just spectacular.
They truly are. Probably the most iconic feature in the solar system besides maybe Earth itself. Those rings stretch out hundreds of thousands of kilometers.
But they're incredibly thin, aren't they?
Surprisingly thin, yes. In some places, maybe only 10 meters or so thick, mostly made of countless particles of water ice with some rock mixed in, like a huge, delicate disk of icy dust.
Amazing. And Saturn itself is light. I read something about it floating.
Yeah, it's less dense than water. If you could imagine a bathtub big enough, Saturn would actually float.
That's bizarre.
It's because it's mostly gas, hydrogen, and helium, like Jupiter. And yeah, besides the rings, it also has amazing moons. Titan is a big one.
Yes, Titan, the one with the thick atmosphere and methane lakes, not water.
Correct. Titan's the only moon in our solar system with a really substantial atmosphere, denser than Earth's actually, and mostly nitrogen. And yes, because it's so cold out there, it has rivers, lakes, even seas of liquid methane and ethane on its surface.
So it has like a liquid cycle, but with methane instead of water.
Exactly, a hydrocarbon cycle. Rain, rivers, evaporation. But all with methane. It's a truly alien but fascinating world.
Wow. Okay, pushing further out. Uranus, the one that spins on its side, the oddball.
That's Uranus. Its rotational axis is tilted almost 98 degrees relative to its orbit, so it basically rolls around the sun on its side.
Which must lead to some pretty extreme seasons.
Extremely long and extreme seasons, yeah. Each pole gets about 42 years of continuous sunlight, followed by 42 years of total darkness. Imagine that.
Unbelievable. And it has faint rings, too? And that bluish color?
It does have faint, dark rings, much harder to see than Saturn's. And yes, that distinctive blue-green color comes from methane gas in its atmosphere, which absorbs red light. Oh, and it's cold. Really cold.
How cold?
Holds the record, actually. Average temperature around minus 224 degrees Celsius. Frigid.
Okay, last official stop.
Yeah.
Neptune. Dark, windy, distant.
That sums it up pretty well. It's the farthest planet from the sun now. It's actually a bit warmer internally than Uranus, surprisingly, which helps drive some extreme weather.
Extreme weather. Like what?
Winds. Neptune has the fastest known winds in the solar system. They've been clocked at over 1,200 miles per hour. Supersonic.
Faster than sound. On Neptune.
Faster than the speed of sound here on Earth, yeah. So giant dark storms appear and disappear in its deep blue atmosphere. It's a very dynamic, mysterious place.
Okay, so that's the main planets. But the solar system doesn't just stop there, does it? There's the Kuiper Belt.
Right. Beyond Neptune, you enter this vast region, the Kuiper Belt. It's like a much bigger, icier version of the asteroid belt, full of countless icy bodies, leftovers from when the planets formed.
And that's where Pluto lives, right? The former planet.
That's its home, yes. Pluto, now classified as a dwarf planet, its reclassification caused a bit of a stir, but it didn't make Pluto any less interesting.
What did we find out about it? I know the New Horizons probe flew past.
Yeah, New Horizons gave us incredible views. Pluto has towering mountains made of water ice, vast plains of frozen nitrogen, like a giant heart shape, even a thin atmosphere that kind of comes and goes with its distance from the sun.
Wow, so it's quite complex for a small body way out there.
Absolutely, a surprisingly dynamic little world.
And Pluto's not alone out there in the Kuiper Belt. There are other dwarf planets.
No, it's got company. We know of others like Eris, Makemake, Haumea. These icy worlds are like time capsules, really. Studying them tells us a lot about the solar system's early days.
And besides dwarf planets, we also have comets and asteroids zooming around.
Definitely. Exactly. Comets are basically icy dirt balls or dirty snowballs, depending on how you look at it. They come from the outer solar system, places like the Kuiper Belt, or even further out.
And they light up when they get close to the sun.
Exactly. The sun's heat vaporizes the ice, creating that glowing coma, the atmosphere around the nucleus, and often those spectacular tails of gas and dust that always point away from the sun.
And asteroids are more rocky, mostly between Mars and Jupiter.
Primarily, yes, the main asteroid belt is there. They're mostly rocky or metallic remnants from the planet formation process that never quite clumped together into a full planet, probably thanks to Jupiter's gravity stirring things up.
So both comets and asteroids are like cosmic fossils. Clues to the past.
That's a great way to put it. Their composition, their orbits, they all hold vital clues about what the solar system was like billions of years ago.
Now, you mentioned moons earlier, especially Jupiter's. Let's circle back to some of the really fascinating ones. There are some that are almost like planets themselves.
Oh, definitely. Some moons are incredibly compelling worlds. Take Jupiter's moon Europa.
Right, the icy one with the possible ocean.
Exactly. Strong evidence points towards a vast ocean of liquid salt water hidden beneath its icy shell, kept liquid by tidal heating from Jupiter's immense gravity.
And that immediately makes you think, life. Could there be life in an underground ocean on Europa?
That's the billion-dollar question, isn't it? Liquid water, potential energy source, possible chemical nutrients. It ticks a lot of boxes for potential habitability. It's probably one of the top places we want to look for extraterrestrial life in our solar system.
So exciting. Oh, we talked about Titan already, Saturn's moon with the methane lakes. So alien.
Truly unique. That thick nitrogen atmosphere, the hydrocarbon rivers and lakes. It shows you just how diverse worlds can be, even moons.
And then there's another Jovian moon, Io. That one's volcanically intense.
Oh, Io is hyperactive. It's the most volcanically active body in the entire solar system, constantly erupting.
Why so active?
Again, tidal forces. It's caught in a gravitational tug-of-war between massive Jupiter and other large moons like Europa and Ganymede. This constantly flexes and heats its interior, leading to non-stop volcanism. Lava flows, huge plumes. It's a hellish landscape.
Wow. From potential oceans to methane lakes to volcanic hellscapes, moons are really diverse.
Incredibly so. And don't forget Saturn's rings again. We talked about them being thin.
Yeah, meters thick, but spanning huge distances.
Right, and they're not solid. They're countless individual particles, mostly ice. How they formed, how long they'll last. Still things we're actively researching. They might be younger than we used to think.
Always more questions. Okay, let's shift gears a bit. How about some just plain, mind-blowing solar system facts? Stuff that makes you go, really?
Oh, there are plenty of those. You mentioned Venus earlier.
Huh?
How about this? A day on Venus is actually longer than its year.
Wait, what? How does that work?
It rotates incredibly slowly. On its axis takes about 243 Earth days for one rotation. But it orbits the sun faster, in about 225 Earth days. So its day is longer than its year.
My brain hurts trying to picture that. Okay, do me another one.
Jupiter's magnetic field. We know Jupiter's big, but its magnetic field is truly enormous and powerful, about 20,000 times stronger than Earth's.
20,000 times? What does that even do?
It creates these intense radiation belts dangerous for spacecraft, and it generates powerful radio waves. Astronomers can actually listen to Jupiter's radio emissions from Earth.
Listening to Jupiter.
Wow.
Cool. Okay, what else?
How about how Neptune was discovered? It wasn't just spotted randomly through a telescope.
No. How then?
Math. Astronomers noticed Uranus wasn't quite following its predicted path. Something unseen was tugging on it gravitationally. Mathematicians like Leverrier crunched the numbers, calculated where this mystery planet should be.
And they pointed telescopes there and...
Bingo! Found Neptune almost exactly where the math predicted it would be. A huge triumph for celestial mechanics.
That is seriously cool. Physics predicting a planet. One more. Maybe about Earth.
Okay, well, Earth isn't perfectly round. Because it spins, it bulges slightly at the equator and is slightly flattened at the poles.
It's just kind of squishy.
Just a tiny bit. It's called an oblate spheroid. The difference is small, but it's a direct result of our rotation.
Huh. Never thought about that. Okay, so we've toured the solar system, uncovered some weird facts, but the big question is, why does studying all this stuff matter? Why should someone listening care about, say, Neptune's winds or Pluto's ice mountains?
Well, on a fundamental level, understanding our solar system is understanding our own origins. How did Earth form? How did the conditions for life arise here? Studying other planets gives us context.
So comparing Earth to Venus or Mars helps us understand Earth better.
Exactly. It helps us see what makes Earth special, how planetary climates work, why Venus ended up so hot and Mars so cold and dry. It informs our understanding of our own planet's past, present, and future.
And it helps us figure out if Earth is unique, or if life might be common out there.
That's a huge part of it. Are the conditions that allow life rare? Or are they common? Finding that ocean on Europa or looking at Titan's chemistry, it helps us assess the odds and know where else to look.
Right, driving that search for life beyond Earth.
Precisely. And understanding planetary climate systems, like that runaway greenhouse on Venus, is incredibly relevant for understanding climate change here on Earth. We get insights from seeing these processes play out on other worlds.
That makes sense. And practically speaking, for the future.
Well, if humanity ever wants to seriously travel beyond Earth, maybe even set up outposts or colonies, we need to understand these environments. What are the hazards? What resources might be there? This knowledge is crucial for future space exploration.
So it's about understanding our past, present, and future place in the cosmos.
I think so. Ultimately, it gives us perspective. Seeing the sheer scale, the diversity, the sometimes harsh realities of other worlds. It really highlights how precious and perhaps how fragile our own planet is.
It makes you appreciate Earth more.
It certainly does. It fosters a sense of maybe cosmic humility, but also wonder.
Well, that brings us towards the end of this particular deep dive. We've journeyed from the blazing sun out to the icy fringes, visited bizarre moons, uncovered some truly strange facts. It's clear our solar system is an incredibly rich and wonderfully weird place.
It really is. There's just so much out there, and we're still learning more all the time. It's been great exploring some of it today.
Absolutely. So maybe a final thought to leave everyone with, considering how specific the conditions seem to be for life as we know it on Earth, but also seeing the sheer strangeness out there. Methane lakes, subsurface oceans, world spinning sideways. What possibilities do you think might exist for life beyond Earth? Maybe in forms we can barely even conceive of right now. Something to ponder.
That's the ultimate question, isn't it? What else is out there, perhaps following completely different rules?
Definitely food for thought. Until next time, keep looking up and keep wondering.